actual T100 touch system. And first of all, I plugged it into my socket. I'm European socket. It should handle it. 230 volts at my socket. At the moment I plugged it in, it started fine and it started running. And the next time actually my plug got loosed, and when I put it back in, it didn't anymore turn on. It was like bam, and it didn't turn on. So it works when you plug in the 12 volt DC power supply. It works, and it means only the AC board is broken. I'm gonna open it and look inside. Okay, so this is how it looks inside. So we have a power support part, and this is 230 volts for AC input and DC input. And as we can see, the DC input goes straight to the cord itself. Yeah, and DC input goes straight to the cords. Well, this is the layout of the board. First of all, the fuse is done. Fuse is located right here. It's where the red wire goes in. This is some Chinese board build out, because if we look like here, does it focus? We can see a really nasty way how to build. Let's take some light in here. If you see like that component over there, that's really nasty. That's not the way to handle the solder things. After all, the layout looks well. There is few components on the power supply board that has a little bit less soldering 10 on it. Here you can see actually the soldering marks. It's like waves over here. I don't know how far the camera can see it, but it means the solder haven't been enough warmed when soldering it. It looks really nasty. Can we see? Yeah, the waveform is right here at this, over my finger there. That's some kind of waveform. I don't hope it's not a big problem here, but still it looks nasty. And this is just so ridiculous. It's one way to do it, but still it is ridiculous. That's the power supply. The 230 volt. 100 to 230 volt power supply. Second of all, the board itself, the main brain board. I haven't opened it, I haven't looked under it. I don't know if I want to even do that, but still we can see here it's really a small amount of used of 10, like here. If you look on the resistor here, we have does it focus here? It's soldered from the other side of the board, probably by hand, and the soldering 10 hasn't come over on this side. It's like a little bit too little soldered. It's on the both sides of the resistors. I don't hope that's gonna be a big problem. Probably it won't, but still, it's just the quality of these builds. The same thing here. It's a little 10 on this wire. I don't know why it does run like that, but I don't care. Yeah, and the capacitor, we can also see that's not really true. It's came that the soldering tin has come true. Actually, here you can see on the resistor still. Focus. There we go. Actually, the soldering tin hasn't come even true on this side. On the capacitor, it's not that bad, but still it is like not enough of soldering tin. So the guy with soldering have been soldering this haven't warmed it up enough and didn't feed enough soldering tin doing the job. When it comes to the banana connections, I would say that's pretty okay. And yeah, well, the capacitor over there, the small one that we can see, it's definitely not true soldered. Yeah, maybe I should take this out and just look it through with the soldering iron. Oh, that looks nasty. I don't know, can I get some light in there? If you look on the transistor, yeah, that's nasty. That's really, really nasty. Well, sometimes that's how you do things. How does that one look actually? Yeah, it looks really bad. Oh man. I'm gonna remove the card from the case and look it through on the other side. It just looks too bad. Plate from the back. Actually, I haven't removed it. It might be done, but still. Some things to tell about here. We have solder here on the power jack, and it's just some weird waveform in the soldering tin. Again, it's like layers in here. I don't know, can you see it? Yeah, you can. This kind of waveform I'm talking about right over here. It means it's cooled in a different, or actually you have put some soldering tin in it, take it out, let it cool, put again, put some more soldering tin, and it has like many layers of soldering tin, and it goes like, it's really not much here, it's some way there is actually some waveform here also, and it goes. I mean, the reason why you put soldering tin on the power jackets are because it's a smaller resistance to the power LEDs. It's just getting less heat and less resistance for the card's own small what is it called? Well, the part where the power is going. I mean the wiring on the card, so we just make it stronger by putting some thin on it, and well, it hasn't worked out really good here. It's like, looks like that. So, and here we can also see some waveform. As it's focused. Maybe a little bit too small iron. Here we have some waveform. This is just something ridiculous, this whole area here. This is like a lot of thin here, and here is just like almost a board. You can see almost nothing, and then we have a lot of thin here. It's just the guys who built this don't actually know what they're doing. Now, after all I said from this board, from this power supply, I decided to fix the fuse quick and dirty. I didn't have the same kind of fuse to solder it out and solder it in again, so I decided to solder a small wire. It's a really thin wire that goes through over the fuse. I think this is gonna, I don't know how much this is gonna, how much the power this wire is gonna handle, but I think it's around 3 or 4 amps. I think it's from RG89 coax cable, I think. Now this is what happened. I don't know how much current it went through, but it seems like the fuse, my short wire, did burn out. I actually put it in there, and yeah, it looks like that. Okay, it didn't work out. Now I connected the battery and the good multimeter inside it, and it's in the voltage measuring mode. It's not in charging, it's just measuring, and it says is 15.427 voltage, and the multimeter says it 15.44 voltage, so the charger shows it's under voltage. So now the multimeter that I'm using is capable of 3 amp meters, so I'm gonna tell the charger we have a 2.5 amp battery, and it's really a 2.5, yeah, I mean 5.2 amps. Battery is 4 cells battery, and now we're gonna start it. And now we see, here we go, 4, 5. Well, that's acceptable. 2 point, yeah, that's really acceptable readings over there. I mean, it's jumping around here too, and when we drawing 2.5 amp, 16 point, I think it's 16.3 voltage around, because that's the voltage are not correct. We're growing 14 volts and 3.5. It's jumping around. You can't read that one. 3.3 amps, I think, would be average, or 3.4, I don't know. So okay, I've been playing around with the charger and measuring it with the lab voltage meter. It's millivolts what it says now, it's just getting somewhere, some power. It's nothing to care about. And actually what I figure out is that there is a resistance in the cables, charging cables, and in the sockets. So if I measurement with a high current like 5 amps from this point, it's gonna show more than from the balancing charging, the balancing socket. And the balancing socket is what we care about, actually, is what the charger care about. And also the meter is getting more accurate when the charging voltage current gets down. So yeah, when we hit the balancing mode, the high voltage when the top voltage when we're starting to balance it, it's getting more accurate with the voltage. And well, it's almost also might be that it's just jump around so much less, it's easier to read. But right now, when I'm charging a lipo battery, I put the voltage to the minimum, 4.18, and it shows me there is like somewhere it's 4.194 or so. It shows too little. The meter shows too little. The real voltage is much more than it shows out. And the error isn't same in every balance board. I mean, the third one is the third cell is the worst. So we're talking about the voltage between the yellow and the white wire. The third one, it says, is 4.161, and just when I measure it, it were say 4.172. Now I've been charging it and been doing some measurements, and I actually can say right now that the balance port is like, for the first cell it's almost accurate. It's off, the voltage shows only 0.001 volts too much. I mean, when it says is 163, it's real voltage with more, or lab meter it says it's 16. Now it says it's 165, so it would say it's 166 or really close. So it's just the last number that it's incorrect. Now the second cell, the same story, it's only 1 or 2 like 168, it might be 1.160 in real life. But the story with the third battery, I mean between the white and yellow wires, it's like the totally different story. If I have 4.16, it's the real voltage is of 4.167, so that's the biggest gap. It's like, I don't know. After all, the charger is useful. You can use it for charging LiPo batteries and pretty many else batteries also. But because of there is a slight difference in the voltage, it shows a little bit too little voltage. It's I would recommend to drop down the charging voltage. So it's default set to 4.20 voltage, and the minimum voltage for LiPo charging is 4.18 volts, and that's what I'm gonna use when I'm charging the batteries. Just because some safety measurement, of course, if you charge it with a little bit over voltage, it won't break the battery. I don't think it's enough to break get the battery to explode, but still it shortens the life of the battery. So it's recommended to I would recommend you guys who will buy this, who have bought the charger or thinking of buying it, to definitely, first of all, don't buy it because it's so bad build quality. But again, drop down the voltage and then you should be good to go. It's really bad build quality, so I recommend everyone to just don't buy it.